First of all, I want to wish everyone good morning, and I hope you and your families are all safe and well. I'm Sherry Brodeur, a program director here in MIT Corporate Relations, program director here in Corporate Relations, which houses both our Industrial Liaison Program and MIT Startup Exchange. Our role is to connect our 250 plus corporate members into the MIT innovation ecosystem, the education, research, and innovation missions that are the academic engine of MIT, and the dynamic startup community that we bring to our corporate members through MIT Startup Exchange. We have over 1,900 MIT connected startups in MIT Startup Exchange, and it's a very important part of our program. MIT's motto is mens et manus, minds and hands, and the driving force here at MIT is having an impact on the world. Never more important than in these times, or these unprecedented times. Working with industry is absolutely essential in all times to helping us make the world better. So I just wanted to take this opportunity to thank you all for both being here today and for all the support of MIT throughout the years. So thank you all. The agenda today is straightforward, but I wanted to highlight a few points. First, please ask questions in the Q&A section at the bottom of your screen. We will be pausing partway through the presentation to take questions, so feel free to ask them early and often. David would really appreciate this being extremely interactive. He will be also asking some polling questions for the audience. There's also an ask here. We will be David will be asking you to complete a survey, and we will follow this webinar with another session to present and discuss the results. The link to this survey will be provided. With that, let's get on to the topic. Resiliency has been a topic on everyone's minds these days. Individual and family resiliency, as well as our healthcare systems, governments, and businesses. We have never experienced such a major disruption as we are living through now, but there have been plenty of times in the past when our lives have been disrupted. Our speaker today has spent his career studying the resiliency of global systems. His past research brings great insights into the challenges we face today, and working with you will help prepare for global disruptions. This may be the new normal as we are confronted with issues such as the current pandemic and the reality of climate change. With that, I'd like to introduce Professor David Simichi Levi, a professor here at MIT in Engineering Systems. He is also the director of the Data Science Lab, founder of several companies, author to too many publications to mention, and a leading expert on business analytics and supply chain management. He will discuss supply chain resiliency and the need for stress tests. David, over to you.
Thank you, Sherry. Thank you, ILP, for the invitation to speak. And good morning, everybody. Let me share my screen. As Sherry said, we are going to focus on supply chain resiliency and the need for stress test. If you take a look at the link to the Data Science Lab, you can find more material related to supply chain disruption, and business analytics in general. So here is an outline for the talk today. I'm going to start with an introduction, a brief introduction, then talk about a model that we refer to as the risk exposure model. This model was developed in 2013, 2014, after events like the tsunami in Japan and the flood in Thailand. The Harvard Business Review article present the detail of implementation at the Ford Motor Company, together with insight from that implementation. The book, Operation Rule, provide more insight and more information about supply chain risk management and the risk exposure model. Once we understand the insight from that model, we will use it to identify strategies that try to find an appropriate balance between efficiency, focus on reducing cost, and resiliency, And finally, I will summarize with key takeaway. A good way to start a talk on supply chain risk and the impact of the pandemic is to review the last 10 years. I would argue that in the last 10 years, we have seen significant increase in supply chain risk. And this is because of successful, in part, because of successful implementations of effective supply chain strategies like lean, like outsourcing, like offshoring, or consolidation. All these strategies have focused on dramatically reducing supply chain costs, but they come with a significant increase in risk. For example, what does lean mean? Lean implies a low level of inventory. Low level of inventory suggests that if there is a disruption, the supply chain will not be able to match effectively supply with demand. Similarly, consolidation, outsourcing, offshoring typically imply that the supply chain is geographically more concentrated in a specific region. This means that if there is a disruption in that region, again, the supply chain will not be able to match supply with demand. And we have seen the impact of these strategies with events like the tsunami in Japan and the flood in Thailand in 2011, or the eruption, the volcano eruption in 2010 in Iceland. Certainly, there are case studies and examples of companies that were able to recover very quickly from these events, from the flood in Thailand, the tsunami in Japan, or the volcano eruption in Iceland. And we can learn from these examples and from these companies, but the magnitude of the disruption that we have seen in the last 3 months is significantly different. And as a result, we need to adjust our thinking about supply chain strategies and the detail of what we implement in our supply chain. So this is just a quick observation about the last 10 years. Let me focus on the last 3 months. In the last week of February, in fact, in February 22nd, I submitted together with PRN, who is a technology executive, a paper to Harvard Business Review. That paper that was submitted on the 22nd of February was published by HBR on February 28th. If you look at the right-hand side, you see a screenshot of the paper, and what was reported by HBR that in 4 days, this paper was viewed more than 170,000 times, with 145,000 unique visitors to that paper. So what did we say that attracted such an interest? Let me read to you the opening statement in that paper. We said in the last week of February that the peak of the impact of COVID-19 on global supply chain will happen in mid-March, forcing thousands of companies to either shut down or dramatically reduce manufacturing and assembly facilities. And in fact, this is exactly what happened. On March 17, European automotive manufacturing companies like Volkswagen, Renault, Peugeot, Fiat, and others reported that they are shutting manufacturing facilities in Europe. And this was not only in Europe. A week later, MIT reported that the week before, meaning the week of March 17, US major automotive manufacturing companies also shut down manufacturing activities. So you may ask, how did we know in February, when we wrote this, it was mid-February, that by mid-March, we will see a collapse of supply chain? What I did, I used the risk exposure model that I mentioned earlier, and back of the envelope calculation to estimate when we will see a disruption in the supply chain. So I want to go with you over the risk exposure model and what insight we can get from that type of analytics. Remember that the risk exposure model was first implemented at Ford, and so I'm going to use a simplified version of Ford's supply chain to introduce the model to this audience. Here is a simplified version of Ford supply chain. On the right-hand side, you see the assembly facilities, and then you see tier 1, tier 2, tier 3, and so forth and so on. Clearly, the detail of Ford supply chain is way more involved than what I'm showing you here, but to get an insight, this will be sufficient. In this process of introducing the risk exposure model, we developed a number of concepts. Let me introduce them one at a time. The first one is what we refer to as time to recover, or TTR. What is time to recover? I look at a specific facility or a group of facilities. In this case, let's look at the chemical supplier where my laser pointer is. And we try to identify how long it takes for this supplier to recover to full functionality after a disruption. When we analyze information from the supplier, we realize that it takes about 2 weeks. Why 2 weeks? Because this supplier right now provides us with the chemical supply from a facility in Asia. If there is a disruption, the supplier can move manufacturing to another facility, say in Europe, and it takes about 2 weeks to ramp up production, so time to recover is 2 weeks. The current pandemic provides us with a way to estimate time to recover, because suppose the next wave start sometime in October, and during that time, you have suppliers in Europe, say in Italy, and Italy is under quarantine, or a specific region is under quarantine for 6 weeks, then time to recover at that event is about 6 weeks. And so different way to estimate time to recover, but whatever way I have to estimate time to recover, I provide information here about TTR for which one of the facilities, or perhaps for a group of facilities. Once I have information about time to recover, I can estimate what I call performance impact. What is performance impact? Performance impact may be either financial impact or operational impact. Financial impact is impact on Ford revenue. Financial impact may be impact on Ford profit. Operational impact may be impact on lost production. How do we estimate performance impact? Take a look at the chemical supplier again, and suppose we remove the chemical supplier for the duration of time to recover, for 2 weeks. We ask, what is the impact on Ford revenue? When I say Ford revenue on the right-hand side, when this supplier is out of the supply chain for the duration of time to recover. We can estimate this, and in this case, we estimated that the impact on Ford revenue is a loss of about $400 million. And we can do the same analysis for each one of the nodes, or in fact, a group of nodes. And this gives us the risk exposure, which is the impact of disruption anywhere in the supply chain on Ford performance, either Ford revenue, Ford profit, or lost production. And I'm trying to emphasize again that this does not have to do with a specific facility. It can apply to a group of facilities located in the same region. Say, for example, in Wuhan, China, during the pandemic, these facilities were shut down for a period of 8 weeks. We can estimate and we can understand the impact of this shutdown on our supply chain. Let's see what type of insight the model provided Ford, insights that perhaps we can learn from. And so I'm going to show you results straight from Ford system Sometimes I will protect the specific identity or a specific spend at a specific supplier, but what you are going to see in the next few slides is direct insight from Ford supply chain. So here is one screenshot of data from Ford supply chain. What I have here, bubbles represent different supplier sites. The Y coordinate represent total spend by Ford at a specific supplier site. The only thing you don't see is the specific values, but the ratio, the presentation here is exactly the way it comes from Ford system. On the X coordinate, you see performance impact, and I measure here performance impact by focusing on lost profit. When we initially started working with Ford, the insight that the procurement people have was that the risky suppliers are typically the strategic suppliers. Let's see what the data and the analytics are telling us. Look at the supplier at the top where my laser pointer is. This is clearly a strategic supplier. This is a supplier with 4 total spend is significant, right? But if you look at performance impact, right, a risk associated with this supplier, I would say it's moderate, right? It's not the highest risk. Here is another strategic supplier, right? Total spend is relatively high, but risk is relatively moderate. The risky suppliers are the supplier at the bottom right-hand side. These are suppliers where total spend is relatively low. In particular, look at the supplier just at the bottom right-hand side. This is a small supplier that provide Ford with product, with component that cost 10 to 15 cents. These are sensors required by each car. If supply is disrupted, you have to stop the production line. What does this tell us? It tells us, and that's the first insight I want to highlight, that risk is hidden in the supply chain. You need to use your data, you need to use analytics to identify where is risk in different parts of the business and develop mitigation strategies that allows you to address these challenges. The second insight that I want to highlight that comes straight from Ford system but is applicable beyond Ford supply chain is here. Here is a screenshot of the system that was implemented at Ford. I'm looking here at all the suppliers that Ford is using for the North America assembly facilities. Different bubbles represent different suppliers. The size of the bubble is proportional to the risk that this supplier, that a specific supplier will have on Ford bottom line. Either, in this case, I'm looking at revenue, but it can be revenue, can be profit, or can be lost production. The higher the size of the bubble, the higher the risk. So to indicate high risk supplier, I color them in a different colors, the blue color. Notice that the blue color suppliers, the high risk suppliers, are not necessarily concentrated in a specific region. It's hard to argue that Asia include most of the high risk suppliers. Some high risk suppliers, as you can see, are in Europe. Some high risk suppliers are in North America, which give us the second insight. Risky suppliers are not necessarily in a specific region. There are lots of talk now about Asia. I want to highlight that data and analytics provide us with specific, where is risk hidden in the supply chain, which supplier and what region and what location are associated with high risk. Let's continue to the next insight provided by the model. Remember that so far I identified a couple of concepts. The first concept was time to recover, how long it takes for a specific facility to recover to full functionality after a disruption. In the case of pandemic, we can use quarantine time to estimate that time. A related concept that provides an important insight is what we call time to survive. what is time to survive? We look at a specific facility and we remove that facility from the supply chain and we ask, what is the maximum time the supply chain can match supply with demand without that facility? It's not zero, because the supply chain is full with inventory, but I can estimate it. So let me highlight an important difference between time to recover and time to survive. Time to recover is an input to our model. It depends on the scenarios that we are analyzing. In the case of the pandemic, quarantine time, for example, can give us a good insight about time to recover for a specific facility in a specific region. Time to survive is an output. It says, if I remove that facility, how long can the supply chain match supply with demand without that facility? Let's look at Ford data to see if there is another insight that we can use. Here is Ford data. I'm looking at time to survive across all Ford tier 1 suppliers. On the X coordinate, you see time to survive in weeks. And on the Y coordinate, you see the number of suppliers with that time to survive. Notice an important observation. There are a significant number of suppliers whose time to survive is very short. These are suppliers that I'm very worried about, because if there is a disruption in some of these suppliers, I will be able to match supply with demand for only a short period of time. On the other hand, if you look at the right-hand side, you can see a number of suppliers, many suppliers even, where time to survive is very long, 40 weeks, even more than 50 weeks. Why we have such a long time to survive, a high time to survive value? Because perhaps these suppliers are sitting on a lot of inventory, or we, Ford, are sitting on a lot of inventory. Here is a saving opportunity. Maybe we can reduce time to survive by 50% by cutting inventory without affecting our resiliency. So this is insight number 3. When you look at the detail of the supply chain, you will find facilities with low time to survive values and facilities with high time to survive values. Those with low time to survive values are those that we are concerned with. A disruption there will create a big impact directly on our performance. On the other hand, the high time to survive value suppliers are the suppliers where we may have saving opportunities, perhaps by cutting inventory of components provided by this supplier. You notice, therefore, that time to survive is an important KPI that help us learn about how resilient our supply chain is. And so if we look at time to recover and we look at time to survive, by combining the two, we get an important insight. And this is insight number 4. If for a specific facility, say facility J or group of facilities, time to recover is shorter than time to survive, we know that if there is a disruption in these facilities, supply will not be disrupted. Because by the time this facility or facilities are back operating appropriately, we can keep on matching supply with demand. But if the reverse is true, meaning time to recover is greater than time to survive, then either we have to shut down manufacturing facilities, or we have a backup plan that allow us to replace this supplier by other suppliers. But there is no way out of this equation. When time to recover is greater than time to survive, we either have a disruption, we need to shut down assembly facilities, or there must be a backup plan. Notice also that when time to recover equal time to survive, then we need to expedite. Why? If time to recover is equal to time to survive, and I have, say, a supplier in Asia, and my assembly facilities are in North America, in normal days, in normal operation, we ship product from this supplier to the assembly facility over the ocean. But if time to recover is time to survive, that takes too long. That may take 30 to 35 days. As a result, in this case, we may need to expedite and ship by air. And so the analysis of time to recover and time to survive tell us where is risk hidden in the supply chain, when do we need to expedite, and as a result, allow us to prepare for the time we need to expedite by reserving logistics and transportation capacity. Let me pause here and ask the organizer to run an important poll that will give us an insight about the participant in this event. And the poll questions that I want to ask is about your supply chain. The first question is very simple. What I'm asking you is to tell us whether you have mapped your supply chain. You know the suppliers, you know the flow of product in the supply chain, and it's a simple yes and no. So we don't know the identity. We just want to know what is the proportion of companies in this event who have a good mapping of their own supply chain. Please submit your clicks and we will see the result when you are done. And once you are done, we will move to the next question. Now, the reason I'm asking this question, just to make it clear, the reason I'm asking this question is because an important part of the risk exposure model is having a supply chain mapping. And having a supply chain mapping requires you to make sure that you have data about suppliers, you have data about the flow of material, you have data about the assembly facility and the manufacturing facilities that are used in your supply chain, because only if we have that information, there is an ability for us to calculate performance impact, estimate time to survive, and therefore determine how much risk our supply chain is exposed to. So we will wait just about a minute to see people responding to this survey. And once the organizer sees that we have enough response, they will present the result to all of us. Once we are done with question number one, I have a follow-up question that I would like to ask. And again, we will collect data from all of you and see what type of results we are getting. Because by combining the data from the first question and the second question, we get an insight about what industry is doing and how prepared industry is for a disruption, and now more than ever preparing for maybe the second wave that may be coming in October or November when the fall time is hitting us. Let me suggest that we show the result for poll one. So if you look at the result for poll one, you can see that about 55% of you said, yep, we have mapped our supply chain, and around 45% are saying we did not, right? 45% companies without detailed supply chain mapping is really an important challenge. Let me switch to the second poll, right? The second question is, do you have a good mapping of your supplier network, right? So while you are responding, I will take note on the statistics from the first question. Okay. So the second question, the question that you see now, is all about your supplier network. And you notice why I'm asking about your supplier network, because you may be focusing on your own supply chain, but the disruption can happen in tier two. And a supplier to one of your suppliers may be disrupted, and that will have a domino effect. And so there are a couple of questions that I have in mind. The first is, do you have a good understanding of your supplier network? And we will see what the results are. And the second is, what do you do when you don't have a good understanding of your supplier network? I will report and talk extensively about that later on in this webinar. But for now, what we are trying to do is to figure out how many companies, or what is the proportion of companies with a good understanding of their suppliers network. And let me connect this with the case of Ford. Of course, Ford had a very good mapping of their supply chain. They know at a detailed level information about each one of the suppliers. When you start moving from tier 1 to tier 2, some of the information is not of the same quality. They know some tier 2 suppliers, especially for sensitive component, but it's not the case that they have complete visibility to the entire tier 2 suppliers. And I'm wondering, the audience here, the companies represented by people in this webinar, what is the proportion that we see in this case? So again, talking to the organizers, if we have enough responses, let's present the results from the second question. And you can see that here the situation is striking. 75% of you said, nope, we don't have a good mapping of our suppliers network, while 25% of you said, yeah, we do have a good mapping of our supplier network. Let me take this because I'm going to use this information later on. All right, let's close this and continue with our discussion, and then I'll take a break in about 2 minutes and address a few questions. So let me finalize this part of the presentation by highlighting some creative solutions that I've seen applied by companies in the last few months. The first is about positioning inventory effectively to take advantage of what we call risk pooling. Remember that this pandemic is such that the peaks in different regions happen in different times. So if we position inventory in centralized location, we may allocate them to affected areas depending on the time these areas are affected. Let me give an example from healthcare. Think about PPEs. Think about masks, think about ventilators, think about gloves and other essentials. Instead of just putting all your inventory one hospital at a time, maybe putting inventory at centralized location and moving them, say in New York State, moving them first to the city because the city was affected initially, and then moving remaining inventory to upstate New York because the second wave happened in upstate New York. And so by allocating effectively and positioning effectively inventory, we may be able to manage the pandemic better. The second, we have seen this many times, even before the pandemic, just identify other alternative suppliers where you may need to pay more. Financially helping critical supplier is part of a recovery plan. What we also saw, companies are changing bill of material, maybe changing recipes to make sure that they are able to still produce some of the products that they need to produce. Probably the most creative one is where you see OEM sharing blueprints of critical component with suppliers who can modify existing tools and machines. And this allows them to produce products that they never produced before. Just in the last 3 months, we saw InBev producing and distributing products they never produced before, hand sanitizer, in the same production line that they used to produce their famous product. And finally, remember our discussion about TTR and TTS and the need to expedite. What we see today, and I've been working with a number of companies in the last few months, using the models that I described, companies look at TTR and TTS and decide to reserve transportation capacity in advance before they expedite, because they know once recovery starts, everybody will be moving product across the supply chain. There will be limited transportation capacity. It will be very expensive or impossible to get capacity. And so they are reserving that capacity well in advance based on the analysis that I described. Let me pause here and ask Sherry to see if there are some questions that we can discuss.
Hi, David. Well, we have several questions, but first I want to ask one. I look at the opportunity that the creative opportunity to be able to retool your business when things like this occur. So is that a new strategy for companies to be able, I mean, is not just reacting as people are now to like AB InBev to create sanitizer, but to be prepared to step in when in a situation like this, the supply chain could be disrupted anywhere in the world at any given time. So I don't know if you have a comment on whether there's a strategy for planning for that.
Very good comment and question. That's why I highlight this as short term. When you see this disruption, you need to find a good strategy that accelerates the recovery process. And I'm listing it here. Once we are done with the short term, I'm going to focus on mitigation strategies before a recovery happens. And I will emphasize this need for balancing efficiency and resiliency. And at that time, I will focus on concepts that allow us to achieve this before the next wave of pandemic or before other disruption happen. And so your question is really important because there are short-term mitigation strategies. This is just quick solution to a problem at hand. And there are long-term solutions that we have to implement in preparation for what I call the unknown unknown, right? An event that will disrupt our business, but we cannot predict.
Excellent. Well, let's take a couple from the audience. I just was very fascinated by that point. So from Ali, what kind of uncertainty modeling approaches are the most useful towards effective resilience of organizations and communities, both in the short and long term?
Right. So this is an excellent question. And you notice in all my discussion, I didn't look at probabilities. I didn't try to estimate the likelihood of a certain event happening, because a lot of the things that we are worried about when we focus on supply chain resiliency are low probability, high impact event. And it's very difficult to estimate these types of probabilities. So instead of focusing on probabilities, I focus on scenarios and try to understand under this type of disruption, what is the impact on my business? Where do I need to develop mitigation strategies? Then take another scenario and ask the same thing, right? Instead of focusing on estimating low probability events that is very difficult, and the two of us can come up with different estimates. You may say, hey, David, the likelihood of this happening is 0.1 percentage, whereas I think it's 0.5. This small difference has a big impact on the supply chain strategy. So I want to go out of the business of estimating probabilities and instead build different scenarios.
Excellent, thank you. Let's take another one from the audience, and then we should probably move on, and we have several more, but we'll hopefully get to those at the end. Do you factor in the logistic lead time when you calculate time to recover and time to survive?
So when I, very good. when I calculate time to recover and time to survive, in the initial model that I did, we did not take into account lead time, but later on we added lead time to the model. So now the model includes lead time. Of course, it increases the complexity, so you need to be more careful, but lead time is important.
Excellent. Should we take one more? Or are you ready to move on?
One more question will be fine.
Supply chain mapping. This is from Adam. What do you do when your suppliers are not transparent about their tier 2 and when your tier 2 and tier 3 suppliers are not transparent because they are critical to your business?
This is an excellent question. I want to devote the right time to discuss it. So let's move on, and you will see I'm coming back to this question, because this question represents a challenge that we see in any supply chain, right? Some suppliers provide you with visibility to their supply chain, but not everybody. And so this is reality, and the question is, how do you address this challenge? I'll come back to that. Okay. Now, I want to highlight that this is not just, what we see today is not just a disruption to the supply side, it's also a disruption on the demand side. As Sherry said, we are running an online survey for many different manufacturing and supply chain companies, and I'm hoping that people on this webinar will participate. Let me take a snapshot of some of the results that we have already seen, and I'm looking at the demand side here. Every bar represents a different company. You can see that some of the companies report dramatic increase in demand. So look at the yellow bar here. This is a consumer product company, dramatic increase in its demand. Here is the brown company. It's a healthcare company, dramatic increase in its demand. But you can see here on the right-hand side, oil and gas companies and retailers, dramatic decrease in their demand. You can see on the right-hand side, at the far right, companies. These are companies in transportation, in the transportation industry, dramatic decrease in their demand. And so one of the key questions that companies in a disruption like the one that we see today need to address is, how do I effectively predict my demand? And so let me show you not only that this is possible, but that your baseline forecast can help us predict demand effectively even under the pandemic. And so I'm going to show you in this slide the result of a collaboration between the data science lab at MIT and a very large CPG manufacturing company. This is a global company. They have seen significant decline in demand. We have worked with them to estimate demand in a number of regions. The question that they ask, how do we do that? And whether we should ignore our baseline forecast that was very effective under normal operation, but is not going, as you will see in a second, not doing a good job under the current disruption. So here is their data without specific values. This is data from one specific region. The green represent realized sales. This is what they reported. You can see that before the pandemic, sales was, in this scale, was very high, but after the pandemic started, a dramatic drop in their sales, right? And if I put on top of it their baseline forecast, the forecast that was very effective in normal operation, you can see it not doing a good job during the pandemic period. The blue line represents this forecast. You can see, for example, that there is seasonality, but there is no relationship whatsoever between the forecast and realized sales in their system. And to highlight this, the red line represents the difference between sales, the green, and baseline forecast. The question is, what can we do? what we found is that if you take the baseline forecast and you combine it with additional data representing the pandemic, in the region that I'm talking about, we use information about the pandemic itself. We use pandemic modeling. Then you can take the baseline forecast and correct using the pandemic modeling and come up with the red forecast, which, as you can see, track very nicely realized sales. The point I'm trying to make is the baseline forecast is very important, but you need to have a system that allows you to quickly add additional data, and this additional data allow us to update our baseline forecast. In the region I'm focusing on, we are using pandemic data, but with other companies, we use pandemic or mobility or other measures that help us understand how carefully lock-in policies are followed in a specific region or a specific country, and this provides us with the ability to update the baseline forecast and get a good insight into the customer demand in a specific region for specific product categories. So let me now build on this and talk about the need to find a good balance between efficiency and resiliency. And I want to start this discussion by talking about the trade-off between the two. And this is nicely illustrated in the following figure. If you look at the y-coordinate, on the y-coordinate, I'm focusing on efficiency from low cost to high cost, from a highly efficient supply chain, low cost, to a high cost supply chain, low efficient supply chain. And on the x-coordinate, I'm focusing on resiliency, from low resiliency to highly resilient supply chain strategies. And the trade-off are very clear. If you emphasize low cost, typically resiliency is low. If you highlight high resiliency, the intuition will tell you that we need to invest a lot, so cost is high. And a company strategy is a point along this trade-off curve. What I want to do is to use data and analytics to push the trade-off curve in a direction of improvement. Because if I can do that, then as you can see, for the same resiliency, I can move from A to B and cut my cost. Or for the same cost, I can improve resiliency by moving from A to C. And notice that between B and C, there are many strategies that do better than A on both efficiency and on resiliency. And that will be the focus of our discussion. How can I improve both on efficiency and resiliency by pushing the trade-off curve in my supply chain? So to do that, the first thing to recognize is that when we talk about cost, we need to focus on total landed cost, the entire cost associated with product and component in our supply chain, from acquiring the component from a supplier through the inventory, transportation, all the way to the production until the product is delivered to the customer. So cost is not just component cost, is what we call here total landed cost. The second is that you need to apply stress tests in order to identify how resilient your supply chain is. And remember, I introduced a couple of KPI. I focus on TTR, I focus on TTS, I focus on the performance impact. But to do the stress test, supply chain mapping is critical. And in this figure, where you see my laser pointer, I basically did the same experiment that I did with you. I asked about 200 participants from different companies, different industries. The two questions I asked you, and I got a similar result. If you look here at the bottom, you can see that 75% of the participants said, we don't have a good understanding of our supplier network. And like you, only 25% said they have good understanding. So the result and the insight are very consistent. I published a paper in Sloan Management Review, in Harvard Business Review, that talk about the need for stress tests and provide more detail about what it means. Now, when you think about balancing resiliency and efficiency, it typically requires supply chain restructuring. And that's what Sherry talked about when she was referring to long-term strategies. We need to diversify suppliers. We need to find the right mix between local and global strategies. And I'll talk a little bit about that in the next few slides. People talk about moving out of China. I believe that China is still going to play an important role. And it's not surprising because it's a huge market. But companies will need to diversify inside China and outside China. Inside China is illustrated by the pandemic. If you have most of your supplier in Wuhan, then you had a problem. But if you diversify, then you may be able to respond better. Now, I want to go back to the question, the last question that somebody asked and Sherry reported. Right? What if I don't have visibility to my supplier network? And we see this many times. I want to emphasize that part of contracts that you sign with your supplier should include resiliency measures. And this can generate a domino effect that allow us to improve our resiliency. Typically, when you think about contract with your suppliers, you think about the cost, price, you think about response time, you think about quality. I am trying to highlight that emphasizing in the contract time to recover is an important part, an important way to achieve resiliency. Because if your suppliers need to commit a time to recover of 2 weeks, say, they need to do the same analysis that you are doing and making sure that they can recover in 2 weeks. And therefore, they need to look at their supply chain. The point I'm trying to make is either you have visibility to your supplier network or you force your suppliers to do the same analysis that you are doing and make sure that they provide you with the appropriate time to recover. Now let's talk a little bit about supply chain restructuring. All the data that I have suggests that this is already happening. And this was motivated before the pandemic by the China-US trade war. At the beginning of March, there was a survey by the Bank of America of about 3,000 companies from about 10 different industries. Many of them indicated that they are restructuring their supply chain. This includes companies in semiconductor, automotive, medical equipment, and part of it is also bringing their manufacturing activities closer to market demand. Some of them are even talking about reshoring, meaning moving manufacturing straight to North America. But this restructuring started to happen and will accelerate after the pandemic. Now, the restructuring is going to be different depending on the industry. Think about apparel. In apparel, I believe restructuring implies moving manufacturing from, for example, China to Southeast Asia and to India, to countries like Vietnam, Philippines, Cambodia, and the like. High-tech is different. High-tech, and we are already seeing that in high-tech. High-tech is all about maintaining some manufacturing in China, there is no question, because this is a huge market, but also building manufacturing capacity closer to market demand. Brazil and Mexico for North America, maybe Eastern Europe, Poland, for example, for European market, but this is happening and this will accelerate. I'm going to talk in a few minutes about life science because life science is even more complex. It's more complex from multiple point of views, one of which, this is national security. If you think about pharmaceutical companies, you think about drugs, this is national security issue that companies need to deal with, so this requires special attention. I want to highlight that there are lots of talks about reshoring and the need to move manufacturing activities to the US or to North America. Reshoring does not guarantee resiliency. And I want to illustrate this with a specific example. One of the main drivers of the increase in risk, as I mentioned at the beginning, is because of consolidation. Lots of consolidation of manufacturing activities to reduce cost. And this implies that there are just few manufacturing facilities. As a result, if one of them is disrupted, the entire supply chain is disrupted. And this is exactly what happened in the food supply chain. In the food supply chain, and I'm focusing here on a specific supply chain, specific example, there are just a small number of plants that produce beef and pork. And this is because of consolidation. Once one of them was shut down because of the pandemic, dramatic impact on supply. Prices to farmers went down significantly, and shortages for a long time was followed. So just moving manufacturing activities to North America does not guarantee resiliency. And also, even for national security types of product, as I mentioned, drugs, and I mentioned pharmaceutical, this may require government involvement. And let me highlight what I'm focusing on by emphasizing life science, healthcare, and food, and the food industries. Why does it require government involvement? It requires because you need to establish stress tests, and you need to make sure that these national security type of companies convince themselves and the government that if there is a significant disruption, they can still match supply with demand effectively. This is much like my idea of stress test in supply chain is much like what we saw in 2008 after the financial collapse. What happened after the financial collapse, after the financial crisis? The federal government in the US, the European Union established banks stress tests to make sure that bank can respond effectively after a financial problem. We need the same thing for industries like life science, healthcare, and food. But this is not a simple issue. And to highlight this, let's talk about pharmaceutical and drug manufacturer. Drug manufacturing a lot include facilities in China and India to reduce manufacturing costs. But it's not only because of the need to reduce manufacturing costs. The production process of many of the chemicals used in drug manufacturing process is highly polluting. As a result, the move of manufacturing activities from North America and Europe to Asia is driven by cost, but also is driven by the fact that the manufacturing of these chemicals is highly polluting. If we want to reshore these manufacturing activities, we need to develop new technology, new clean chemical technologies. That takes time and that takes investment. Time, the estimate of experts in the field, and I'm not one of those, they estimate that it takes at least 5 years to develop these types of clean manufacturing technologies that require investment either by private sector or by the federal government. But because I believe this is national security types of product, we need both. We need to make sure that we have a stress test, and we need to make sure that the investment in there that allow us to move some of these manufacturing activities closer to North America or to Europe, so that when there is a disruption, we are able to recover quickly. Let me summarize with key takeaway. In my opinion, supply chain restructuring is not only happening, it will accelerate. It's happening because of initially the China-US trade war, but it's accelerating because of what we have seen now. One of the things that helps the restructuring and motivate moving manufacturing closer to market demand is automation. As automation is taking off, this is not about low labor costs. This is about people with the skill to work with the new technology that comes with automation. Reshoring is not the solution. If you want to know whether the supply chain can match supply with demand effectively after a disruption, you need to apply stress tests. And finally, I believe that for certain national security industries, we may need federal government to be involved by establishing, for example, the detail of stress tests and by requiring companies in the 3 critical industries that I identified to provide evidence that indeed their supply chain can recover effectively after the type of disruption that we have seen in the last few months. Let me, before I stop, let me highlight the survey, and I will ask the organizer to put it in the chat box, the link to the survey. It takes no more than 5 to 10 minutes to provide information in the survey. We will greatly appreciate those who respond, because this helps us understand and develop better strategies for supply chain. We are committed to sharing with all of you the information from the survey. Sherry will connect with you later on and invite you to a session where we are happy to provide insight from the data collected and analyzed in this process. Finally, I should add, we will provide the participant with a PDF version of the slides. The last slide provides you with links to many of the papers written by the MIT Data Science Lab. These papers provide more insight that complement what I presented in this webinar. Thank you, and I can take questions if we have time.
Well, thank you so much, David. That was fascinating. We actually have, I want to say, just reiterate very quickly. First, thank you all for attending. Those of you that have to leave, I want to let you know we will be sharing the presentation. Please reach out to any of us of questions that you have, but we will stay on since we have a significant number of people still here to ask David a few questions. I think, David, it's okay for you to stay an extra five or 7 minutes?
Sure, no problem.
And then please feel, if you don't feel your question was answered or you want more information, feel free to reach out to me or others in corporate relations or David directly for answers, because we want to help you. So with that, I will thank you all that have to leave. And with that, I'll go into questions. So here's a question. I'm going to go down the list since there's so many, I don't have a chance to read them all and prioritize. So reducing inventory for increasing saving, I guess it could go either way, will also increase the time to survival. Is there any threshold or standard rule how you would think about reducing inventory and still not make it a bottleneck?
Yeah, so very good observation, right? There is a relationship between inventory and time to survive, and this is nicely illustrated by the slide that I had before. Let me go to the slide. Now, the key insight here in this slide is that it's not about just reducing or changing inventory level. It's maybe about positioning inventory differently in the supply chain. Because if you can position inventory differently in the supply chain, you may be benefiting from two KPI. One is you get a little bit longer time to survive, and the other one, it allows you to reduce cost. And so just focusing on the same inventory strategy and reducing inventory, of course, is going to affect immediately time to survive. But if you reposition inventory effectively in the supply chain, you may be able to achieve these objectives that I mentioned. Increase time to survive while reducing your cost.
Excellent. Okay. Let's go to the next one from Adam. Time to survive again. When you identify the suppliers with the highest time to survive, and you want to take this opportunity to reduce inventory on hand, what is the cost of this in high MOQs? I don't know what that means.
Minimum order quantity.
Oh, okay.
So
creative ways to reduce the inventory, such as stocking programs.
Yeah, so a very good point, right? As you are trying to reduce inventory, and if you remember my slide, I don't think it's on the screen, but if you remember one of my slides, I had many suppliers in Ford supply chain with very, very long time to survive. And so there we reduce in. Now, you are right that you have to be careful not to affect minimum order quantity. But when I talk, and this is the case of Ford, suppliers and specific component where time to survive was 50, 60, 70 weeks, reducing it from 50, 60, 70 weeks to maybe 30 weeks has no negative effect on minimum order quantity. And that's why I'm looking at the extreme and telling myself, oh, there are really opportunities to cut my cost by reducing inventory of this component. Of course, sometimes reducing that inventory is in conflict with MOQ, completely in agreement. In that case, you cannot do it. But our experience, and we have done this at Ford, we have done this for a large telecommunication companies. We have done this in multiple industries for multiple companies. We find that those with 50, 60, 70 weeks time to survive, you can cut it without affecting negatively MOQ.
Excellent, thank you. I'm seeing people staying on, so I'm going to keep asking for a few more minutes, if that's okay.
Sure.
This is, how is Ford using this information exhibited in earlier slides to improve supply chain and lower risk?
Say it again, I couldn't hear.
Oh, how is Ford using this information exhibited, I mean, the case that you gave regarding Ford to improve supply chain and lower their risk? Very
good. So if you remember one of my slides, I don't think we have it on the screen, but I can see it on my screen. In one of my slides, I showed you bubbles where on the Y coordinate, we had total spend by supplier side, and on the X coordinate, we have performance impact. Ford used exactly that type of information to develop segmentation strategy that provide different risk mitigation for different segments. For example, one segment, it was all about increasing inventory. Another segment, it was all about requiring a supplier to have multiple facilities in different regions. Another segment, surprisingly, was about redesign of some components so that you have standard components that allow you to give more volume to a specific supplier, and in response, the supplier is required to have another facility in a different region. So this is about segmentation, not supply chain segmentation. This is segmentation of suppliers, different segment, different mitigation strategies.
Excellent. Okay, we'll take two more, and then I think, Giro, our organizers can help make sure we take down the other ones and answer those as we follow up. But the next one is risk pooling is prudent, of course. However, is it different from the prudent supply chain practices like decoupling with inventory buffers, postponement across the supply network? And are you thinking about a different approach than these?
No. Risk pooling is important, and I agree with all the concepts that you mentioned. these laws of physics that are important in supply chain have not changed. They are important in normal operation and they are important in disruption. What I'm trying to do is to build on these laws of physics and take advantage of them as I think about disruption. And as I mentioned, for example, when I think about positioning inventory, now it's not risk pooling to take advantage of variation in demand associated with seasonality or with different products. This is variation associated with a pandemic impact in different regions at different time. So it's the same set of laws of physics that you have referred to, but I'm trying to build them into my risk exposure model to take advantage of those.
Excellent. So now we are at 12:50. I'm going to ask one more because I think it's interesting. Earlier, we used to have efficiency versus responsiveness, and now we are talking of efficiency and resiliency. How do we manage both, or should I say all three? You have to.
Very, very, very nice. This is somebody who knows how I talk about supply chain in general. The point I'm trying to make is there are multiple KPIs. One is efficiency, one is responsiveness, one is resiliency, later on quality. You need to look at all of them. But it's hard to show all of them on a slide. So every time what I focus on, only two of them. When you do the analysis for your supply chain, look at responsiveness, look at resiliency, look at efficiency. And what you want to do is to use data, analytics, visibility to push the trade-off curve in a direction of improvement. As you do that, you are going to improve along multiple KPI. Let me summarize with the following key insight. Taking advantage of data, taking advantage of analytics, taking advantage of automation is a new set of capabilities that allows supply chain executive to improve business performance along multiple KPIs.
Excellent. I'm just typing in the chat session for everybody. I'm typing my email. So you have that. You can follow up with me. I know we have 9 or so more questions. I don't want to continue at this point because we've gone over. I know, David, your time is precious, but I will make note of the questions and I've typed my email into chat. Please feel free to reach out to me. I can help you connect with David for follow-up projects and work or anything that you're interested in. We will also follow up with all of you regarding the survey and plan a discussion session in a, whenever David finishes his analysis to report that out and continue the discussion. So thank you all and enjoy the rest of the day and the summer. Thank you.
Thank you, everybody.